Hopefully everyone can see my slides. All right, so as Michaela mentioned earlier, I'm talking about a project we've been working on in NIST called BLOSSM, or Blockchain-Based Secure Software Assets Management. What is BLOSSM? BLOSSM is a proof of concept permission hyperledger fabric system using Fabric 2.2, implemented under a CRADA with DHS, NIST, and UMBC, with the goal to demonstrate a SWID-based software acquisition management service for federal software assets. So there's two main outcomes that we hope to achieve with this effort. The first is security automation and mutual trust. We aim to demonstrate security assessment automation with continuous ATOing and continuous monitoring using OSCAL, which Michaela mentioned before. We are proposing an approach to build and maintain mutual trust among peer nodes and multi-agency consortium based on the NIST Special Publication 847 Revision 1. The second outcome is a SWID-based or software identification-based software acquisition as a service. This addresses the President's management agenda and the Quality Service Management Office's missions by enabling upwards aggregation of IT software acquisition at the U.S. government level and downward distribution, sharing, and recycling of these software assets among different U.S. government agencies. This will also allow us to track the use and installation of different software assets. So this is the overall architecture of the demo I'll be showing. It's not the final architecture of the pilot, but it's what we're working with right now. So like I said, it's using Fabric version 2.2, and we run it on an Amazon managed blockchain. We deploy a series of smart contracts that fit our use case. In that red box on the screen, that's where the smart contracts are. That is also where the NGAC policies reside. And I'll get into NGAC more in a little bit. So level above, in the diagram, a level above the NGAC component, you'll see 3 peer nodes, which represent each peer node represents one agency on the channel. The first one is a Software Asset Management Service peer node, or SAMS. And then we have a peer node for the Agency 1 and Agency 2. And each member has their own certificate of authority. All 3 members are joined to the acquisition channel. And for those who aren't used to hyperledger fabric, a channel is basically a ledger or a blockchain. Yeah, so the SAMS member, whose peer node we see on the screen, that is going to be the managing member of the network. And basically, they're in charge of making available software assets for other government agencies to acquire and use. All right. So the second aspect of our architecture is the use of private data collections, which is a hyperledger fabric construct. Private data collections are basically a way to store sensitive data on a ledger with several agencies joined, but restrict who has access to that data. We have 2 main collections. The first is the catalog collection, and that's basically the catalog of assets that are going to be available for leasing. And then we have the license collection, which is a collection that just stores the licenses that are available, and only the SAMS member or the managing member of the network will have access to that. Next, we have the Agency 1 and Agency 2 collections. Those are just collections that are shared between the managing member and each agency, so they can share sensitive data without other members on the network gaining access. So we have 3 smart contracts. The first is accounts, so we can manage accounts on the BLOSSM system. We can update account statuses and provide ATO attestations. We have assets, which allow us to onboard and offboard assets, view assets, and then check out and return assets. And the last is the SWID smart contract, which lets us report and track the use of software licenses. Okay, so I'm going to get into the NGAC aspect of it, which is what I really want to focus on in the rest of the talk and the demo. So first of all, for those who are unaware of NGAC, Next Generation Access Control is an ANSI Insights attribute-based access control standard. Policies are represented in a structured graph with nodes and edges. The rules for how that graph is structured are listed in the standard. In order to make an access decision, we do simple graph traversal algorithms. And in a decision, multiple policy classes can be evaluated so that a user has to have access in each policy class in order to gain access to a resource. We have prohibitions, which are basically just denying permissions on a resource. And these are evaluated after that graph traversal I mentioned to deny those permissions. And finally, we have obligations, which allow us to dynamically change the graph in response to events. And dynamically changing the graph allows us to dynamically change the access state at any given time. So next, I'm going to talk about how we implement them in the smart contracts. So first of all, we define the policy in code using a Golang library. Since that policy is in code, it also gets packaged with the chain code that gets deployed to the Fabric channels. This means it's a subject of the lifecycle endorsement policy. So we have a custom endorsement policy, which basically says the managing member, the SAMS member, and a majority of the other members on the network need to approve the definition of a new chain code in order for it to be committed to the channel to be used. This lessens the chance of malicious code being committed or buggy code because each member on the channel is allowed to inspect the source code within their own environment before they approve it. They don't have to take the word of a fellow member. They can do everything themselves. The NGAC policy checks are embedded in the smart contract functions. So the smart contract functions are effectively the policy enforcement point. They call the policy decision point, which loads the NGAC components, the graph, the prohibitions, the obligations into memory and evaluates a decision at that time. This is a quick slide on how we deploy the NGAC policy. The NGAC policy is stored in the catalog private data collection. Only public information is stored as the policy. Private info such as user identities and stuff like that is stored in that agency collection that only the agency has access to. And you'll see in the middle of your screen is the actual definition for the collection we use in Hyperledger Fabric. This is basically saying the SAMS member is the only member authorized to store the data in this collection. But we set a field called member only read to false, which basically means a member not authorized to access this collection can target the SAMS member to run a query. And at that point, we deploy the NGAC policy to see if they're allowed to access certain data and return it, or we return a access denied. Another important point to note is that because only the SAMS member is listed, they can't actually disseminate any of the data to other peers of other members. To provide a quick summary of the policy we have implemented, each organization registers an account and they define 3 roles. We have the system owner, the system admin, and the acquisition specialist. All 3 roles kind of have different responsibilities in the system, and I'll show that in the demo in a few minutes. Every user in an organization is subject to its status policy. There are 3 possible statuses: authorized, not authorized, and pending. An organization being assigned to one of these statuses can change the access state for all users in the organization, and that's done through obligations. We set an event, the event being status being updated, and then in response to that, we change the NGAC policy to allow or disallow access to data. Okay, so I'll give a brief kind of preview of what the demo is. Like I said, it's a Fabric 2.2 network deployed on Amazon Managed Blockchain. There's 3 organizations. There's the SAMS or managing member, the NIST and SHD members. The starting state of the demo is that both NIST and SHD have been approved to use the BLOSSM system. NIST has a waiting or pending, waiting for ATO status. SHD has been authorized, and so we'll pick up where NIST wants to be authorized and acquire software licenses. Okay. All right. So this is just a simple UI that we created to query and write data to the blockchain. It's deployed as a single application where we can easily mock which user and peer and member we're accessing as. In a real world deployment, this would be totally separated, all on different systems. Okay, so the first thing we're going to do is we're going to submit a get account request, and this long series of characters is just the ID for the NIST member. Amazon Managed Blockchain formats member IDs like this. And we're going to submit the request as the SAMS admin, or the admin user for the managing member of the network. So we see we get some data back. We can see the status again is pending ATO, and we can see the users who are assuming the roles within the BLOSSM system for this account. So the first thing we're going to do is we're just going to try to poke and prod the system to make sure that, you know, users who are authorized to do things can, and those who aren't can't. So the first thing we're going to do is we're going to request a checkout assets. We're going to initiate this command as a NIST client, and since we have that pending status, we won't be able to do so. So we'll go ahead and just insert some dummy data here, and we'll submit a request. And we get an error message in response that they do not have permission to do so. And that's just because of that pending status. So what do we need to do to update that status? First, we need to upload an ATO. We'll just give a quick test value. And just to note, this isn't like a full comprehensive ATO. This is just the ATO attestation. And we'll submit this as the system owner of the NIST member. And we get a OK response. And so next, say we get a little gung-ho, we've uploaded the ATO and we want to try to get some assets. So we'll go ahead and call the get assets function and see what happens. And again, don't have permission to do anything because we don't have that authorized status. So the next thing we'll do is update that status. We want to update the account for NIST, and we want to make it authorized. First thing we're going to do is submit it as the NIST client, just to make sure that users can't update their own status. That is only a permission that the managing member admin has access to. So we'll go ahead and do it again. And with the SAMS admin, and we get an OK response. So now, if we invoke the get assets function again, using a client from NIST, we no longer get an error message, but we get the assets that have been added to the ledger by the managing member. Okay. And to show some extra information that we track, if we get some detailed information about this member, oh, I'm sorry, I skipped ahead of myself. So the next thing we're going to do is actually request a checkout for the NIST member. And this is the same request we made at the beginning. Now it works because they've been authorized to do so, and that NGAC policy has changed because of that updated status. So the next thing we're going to do is, just as the SAMS admin, we're going to approve the request to acquire the licenses. And I skipped over it, but I just acquired one license for one of the sample assets that we have on the ledger. Okay, so now if I call get licenses for NIST for the asset 101, we can see we now have a license, access to a license, and the expiration date. So next thing we'll do a simple query of the asset to get some detailed information as the managing member's admin. And this will give us some detailed information about the asset. We have all the licenses, the available licenses, and then we track which members are currently checked out, or which assets are currently checked out by a member. Okay. And then, for example, if I were to run the same command as a NIST user, we'll get a little bit different data returned, and that's because of that licenses collection I mentioned in the slides. That contains all the private or sensitive data of the asset that can't be seen by anyone outside of the organization or outside of the managing member. So the last kind of phase we'll do is we'll report or we'll simulate the reporting of a software identification tag. So this is basically reporting the use of a license that we've checked out. And so we'll just give it some random values. Test the license that we checked out is test asset 1. And we'll give it some just sample data to make up the SWID XML document, which is the actual definition of the software identification. We'll have all of the information about the installation and the use of it. Okay, and we'll submit that request, and we get okay. So now we can track which software identification tags have been reported to be used with an asset. So for the NIST member, and submit a request to all the assets or all the SWIDs associated with an asset. And you can see here a history of all the times that this member has checked out a license for this asset and reported some kind of use for it in an installation. And the last thing we'll do is we'll simulate recycling these asset licenses so that they can be used again. So we've initiated a check-in process. Now we just need the admin user to complete it. And I inadvertently helped myself in the demo. I tried doing that as the NIST client and I get a permission error. So we'll go ahead and try that again as the SAMS admin. And we get an OK. So the last thing we'll do is get the asset again. And now both licenses are in the available licenses. We don't have a record of the NIST member having checked out a license, but that's just the current world state. The history of transactions is still stored on the ledger. And we can now reuse a license that has been returned. Okay, so that's it. Just a quick what's next. We're going to be working on the security automation and mutual trust with continuous ATOing and monitoring using OSCAL. And we hope to create a multi-agency pilot demo created on DHS infrastructure as a service to show this federal software acquisition use case. Okay. And to contact us, just email BLOSSM@NIST.gov.